Welcome to the Explainer. So today, we're going to look at how India is taking on a massive global problem in the supercritical world of semiconductors. And honestly, they're doing it in a surprisingly clever way by basically turning their university classrooms into actual chip factories. Okay, so to really get this, we first need to understand the sheer scale of the challenge the entire world is up against. And this isn't just some niche industry problem. This is a huge deal for, well, pretty much our entire digital future. So get this. By 2030, the world is going to need over 1 million, that's right, 1 million new skilled professionals in the semiconductor industry. That is a staggering shortfall of the very experts we need to design and build the chips that power, well, everything. And this chart just lays it all out, doesn't it? As we all demand more AI, faster phones, and smarter everything, the need for chips is just skyrocketing. But the supply of people who can actually create them, it's lagging way, way behind. And that gap, well, it could literally slam the brakes on innovation worldwide. So with that huge global problem in mind, let's zoom in on this really unique solution that's starting to take root in India's universities. And they're not just stuck in theory either. They're building a real, practical pipeline for talent. So what's their answer? Well, it's this program called Chips to Startup, or C2S for short. And the whole idea here, launched back in 2022, is super ambitious, but also really simple. Let's create a stream of talent that's ready to go from day one by putting the entire chip design process right into the university classroom. But here's the really clever part, the secret sauce that makes it all work. It's called the shared wafer model. Think of it like a carpool for computer chips. Seriously, instead of every single student project having to pay for an entire silicon wafer, which is crazy expensive, a central group gathers up dozens of designs and prints them all together on one wafer. This just slashes the cost and makes it possible for everyone to get involved. And this is the absolute game changer, right? This takes students way beyond just messing around with simulations on a computer. They get to go through the whole cycle, from their digital design to submitting it to getting a real physical chip back in their hands to test. That's stuff that, until now, was pretty much only for engineers already working at the big-name companies. Okay, so that's the idea. But is it actually working? Let's look at the results, because the numbers here are pretty wild. First off, just look at the buy-in. We're talking 46 different academic institutions across India are already on board. So this isn't some tiny pilot program in a couple of places. No, this is a massive, countrywide effort.
And all those schools, they're getting stuff done. Students have already submitted 122 unique chip designs to be manufactured. 122. Just think about that for a second. That's a huge wave of creativity and real engineering moving from concept to reality.
And this is where it all comes together. 56 of those designs have now been fully made, packaged, and are back in the hands of the students who designed them. They're not just getting a grade, they're literally holding their ideas.
And get this, it's not just for practice. This work is sparking some serious innovation. We're talking over 75 patents have been filed because of this program. So students aren't just learning a process, they are actively building India's future in tech.
Okay, those numbers are incredible. But let's zoom back out for a second. How does all this classroom work connect to that huge global workforce problem we started with? How does this really translate into strength for the industry?
Well, it connects because the focus here is super practical. These aren't just theoretical, abstract projects. The chips these students are designing are aimed at the big league sectors: defense, telecom, automotive, the exact industries that are crying out for new talent right now. And this isn't just happening by accident. The program has some really clear and, pretty ambitious 5-year goals. The target is to crank out 85,000 industry-ready pros, help kickstart 25 new semiconductor startups, and move 10 new technologies from the university lab into the actual industry. It's about building the whole shebang, the entire ecosystem. So let's be real for a second. Is 85,000 people going to solve a global shortage of 1 million? Of course not. But like the experts are saying, that's not really the point. This is about laying the foundation. It's a massive first step to make India a serious, long-term player in the global semiconductor game. So all of this leaves us with one big question. As every country on Earth is scrambling to build up its own high-tech workforce, could this Indian model, this direct pipeline from the classroom to a real fabricated chip, be the blueprint that everyone else starts copying?